Hey everyone, hope you're doing well wherever you're watching this from. My name is Aderinokun, and I'm really excited to be speaking to you all today about the state of progressive web apps in 2021. So before the era of smartphones and I guess like smart everything, websites and native applications, which were essentially limited to like just desktop applications, existed side by side in harmony. So they had very different capabilities and functions, and so they just served different purposes. So websites were just more about passive information sharing, and desktop applications were more where you like got stuff done. They were more interactive and largely like not even connected to the internet. And then we had the introduction of smartphones, which started to blur the difference between what's like a native application versus what is a website. So, specifically, with the introduction of the iPhone, we now had a world where your phone was all these different things. So, it was an iPod, something that was previously just like one device. It was a phone, something that was also previously one device. And it was like an internet connection or connected device. So, something that was previously like basically just your desktop computer. And now all these different things could be one. And thus began the app craze. So suddenly a native application was also connected to the web and could do a lot of the same things that websites could do, plus even more. And on the other hand, websites were really struggling to keep up with these same benefits of native applications. So mobile websites were often less usable than native applications. So websites were obviously originally built just for desktop devices. So they didn't really adapt well for mobile. And most websites look like this example on the left. And even when the concept of responsive design came about in about like 2010, it still took a while to become commonplace. And even with that, responsive websites, they became more usable, but they weren't really that comparable to native applications, which were able to like be built and fully utilize like the space available. They were like dedicated to that particular space. And the web in general was also like less capable than native applications. So, like I mentioned, the web was mostly passive with less interaction before. So it lacked the features that made mobile apps like really engaging. Things like integration with the device, so being able to like pull your contacts lists, personalization, so being able to like tailor the experience to your particular device, and stuff like push notifications just for like better engagement. And websites were also harder to access. So native applications had a dedicated visual space on your screen. So they were just like one click away from full immersion. But with websites, they were all lumped under the same app. So like Safari. So if you wanted to send a tweet via like a website versus a mobile app, it would be a lot more taps, a lot more steps to get there. And critically, websites were not available offline, and this severely limited how and when they could be used. So even if a mobile application wasn't all that usable without connection, it could at least still be opened, and that was still a better experience than getting like the offline dinosaur or something. And so apps overtook websites in terms of usage on mobile. So if you are on your phone, you're likely using an application, not a website. And since more and more people were just spending time on mobile compared to desktop, then people just started putting a lot more effort into developing just for mobile. And this led to the rise of the mobile first or mobile only applications. So things like Instagram launching only on mobile with no web component and still being like wildly successful. And that brings us to 2016. So where websites were really behind mobile applications. So they had the advantage of being like open and accessible to anyone, anywhere, but they were lacking in pretty much everything else. Like mobile apps were more usable, more capable, easier to access, and available offline. And I like how this was visualized in this graph from the web.dev blog. So native apps are really great in terms of capabilities, but they're poor in reach since they're closed off to a certain ecosystem. And then web apps, on the other hand, are excellent with reach, but are lacking in capabilities. So, of course, the question is what can be the best of both worlds in terms of having both the reach and the capabilities? And of course, the answer was progressive web apps. And they're actually defined by this exact intersection. So they use modern web capabilities to deliver a user experience similar to native applications. And they do this while maintaining the main benefit of the web, its reach and low barrier to entry. So essentially, progressive web apps are the best of both worlds. And there are three core features that make a progressive web app. So it needs to be capable, reliable, and installable. By capable, we mean that progressive web apps must take advantage of the modern APIs, which put it on the same footing as native applications. So for example, getting like push notifications using the web push API, or getting access to like the contacts book on the device with the contacts API, and so on and so forth. So by reliable, we mean that a progressive web app should feel fast and dependable regardless of network connection. So in essence, nothing should slow down a progressive web app. And in fact, they should take an offline first approach. So they should think of connection to the internet as more of an enhancement and provide a base experience that doesn't depend on being online. And this is probably the most drastic difference between traditional websites and progressive web apps, since the former were defined by their access to the internet. And finally, progressive web apps need to be installable, meaning that they can be installed to the device as a standalone application and used outside of the browser. So they should also be integrated with the system like other native applications. So for example, being accessible by an icon on the home screen or within the app drawer or wherever native applications live on the particular device. And tying all these three concepts together is progressive enhancements. So progressive web apps are so called because at their core, they're applications built with progressive enhancement in mind. So meaning that none of the extra features should be implemented at the detriment to having like the core standard website experience that we've always had. So how did progressive web apps live up to this dream back in 2016? So first, how capable were they? And in order for progressive web apps to really rival native applications, there are some capabilities that are really critical to have. So push notifications and badging for engagement, background fetch and sync. So the app still has the concept of existing and working without the page being actively used or even open. And then access to the device system. So things like files, contacts, settings, which help with personalization. And there are definitely other great features that are important, but I'm just kind of picking these as the most important for something to really feel like a native application. And unfortunately, back when progressive web apps were introduced, these APIs were just not ready yet. So push was just starting to be implemented in Chrome. Background sync and fetch wasn't a thing at all, and neither was access to the file system or any of these other APIs. So in essence, we had to do a lot of this in our code, and it's obviously still a valid and recommended way to write our code for the purpose of progressive enhancement. But unfortunately, most of the time it was like the same old, like I guess boring code that ended up being used. And what this meant was it was just harder to justify spending the time developing the awesome thing when it was hardly ever going to be used. So unfortunately, the web wasn't really quite capable yet. And what about reliable? So were we able to create applications that work well independent of network? And to have a website work independently of the network, we need to use service workers. So service worker is a script that runs separately from the web page and can perform specific features independently of that web page. So this opens the door to a web app being able to exist and function outside of the page being open and the user actively like having to interact with it. And in order to make a web app work independently of the network, the service worker is used as a sort of like buffer between the web page and the cache or the network. So for example, if the connection to the network is like unreliable or absent, the service worker can instead return a cached response. And that's just one of the things that we can do with service worker. It's a really powerful web technology. But using a service worker back in 2016 wasn't all that great an experience. The first issue back then was their support. So like with everything else I've mentioned, it was essentially a brand new technology and hadn't been adopted in a lot of browsers. So although it was available in like Chrome and Opera, it just wasn't so widespread that we could guarantee a significant amount of users would even have it enabled in the first place. So it had all those same issues as the other features in that the case for spending time on them just wasn't really that strong yet. But arguably, the main issue with service workers was just how difficult it was to use and integrate within an existing project. One of the most prevalent problems that would occur when trying to use a service worker was it getting stuck in the waiting stage, essentially forever. So there's these 6 stages in the life cycle of a service worker. So all the way from the file being parsed to it being like the active service worker in control of the page, and then finally becoming redundant as a new service worker takes over. And what would commonly happen actually is that a new service worker will get stuck on this like waiting stage because the old service worker will just like never be released. And this could happen for a number of reasons, like a user having like a browser tab open somewhere with the page, like keeping the old service worker activated. But it was essentially a real pain to debug. And the solution to this was to use like the self.skipWaiting method, which would essentially just eliminate that waiting stage. But for a lot of people, like the damage was done essentially, and service workers were just thought of as really difficult to use. And another issue with using service workers back then was that it's essentially required a complete re-architecture of your application. So the prevailing advice for how to architect like a progressive web app was to use this app shell model. And this is just a way of architecting your application where you would have like an app shell, which is like the minimal HTML, CSS, and JavaScript that's required to power the UI. And you'd have that kept in cache, which could then be loaded instantly. And then the main content of the page would be loaded from the network or local storage as needed. So back when I learned all about this, I wanted to put it into practice. So I created this progressive web app version of my blog, Bits of Code. So on the left, we have this like app shell. And then on the right, we have what it looks like when the articles are actually being displayed. And this is what the markup for that page looks like. So a shell without any content. And this is what is saved to the cache. And then in my service worker, I respond to network requests with either like what's saved in the cache, or if it's not there, just like a regular network request. And then in my main JavaScript file, I fetch articles that like were previously stored in the browser database. And in this case, I'm using IndexedDB. So the articles are loaded and displayed essentially instantly. And then after responding first with the local data, I then update the articles in the background with a regular network request. And of course, if there's no service worker, I just kind of don't bother with that at all. And I just like fetch and display the articles from the network like any other web app. But one thing you'll notice is that this is like a separate application from my usual blog. And this is because it wasn't all that clear how to integrate this model with an existing website or app. Since it was new, there wasn't really a straightforward or known way to use it with the tools and frameworks we were already using. So in most cases, it kind of had to just be a new project. So although the tools were technically there to make progressive web apps reliable and work offline, in practice, they weren't really able to be used all that well. So we can actually say progressive web apps generally weren't all that reliable either. So finally, were they installable? And as you would expect, the answer is like not really. So the feature of being able to install a website or as a native application was termed like add to home screen. And that in itself is a bit of a problem, but we'll kind of get to that later. But as you can see, the support for the feature was limited to Chrome. And how it was implemented in Chrome was also a bit of an issue. So the app install banner wasn't something that like we as developers could control ourselves. The browser determined when like the banner would show up. And there were 3 requirements for the banner to show up. So a manifest JSON file, a service worker, and then this third thing like visit frequency heuristics, which is as vague as it sounds, but it essentially means that the banner would only show up after Chrome thought that the user had visited or engaged with the domain enough to show an interest in actually like installing the application. And it's like understandable why these barriers were put up, because we didn't obviously want a bunch of like spam websites to start disturbing users with like banners everywhere. But what it meant was that add to home screen was just not the same thing as installing an application. All it did was literally add the website to the home screen like a bookmark, but there just wasn't any much deeper integration into the system than that. And even the experience wasn't the same. So control was taken away from both the user and the developer. So it wasn't really a consistent or dependable experience. So unfortunately, progressive web apps didn't really meet the bar to be called installable either. So across the board, progressive web apps weren't really living up to their name. But what about now? So 5 years on, what's it like developing and using progressive web apps in 2021? So we've definitely seen progressive web apps being used in a lot more cases today than ever before. So basically every major application has a progressive web app version, although they're mostly in addition to like native applications that also exist. There's actually an estimated like 1.5 million websites that are considered to be installable as progressive web apps, with tens of millions of installations happening every single month on Chrome for Android alone. So what can we do with progressive web apps today? And as you'd expect, we are definitely in a much better position when it comes to web capabilities than we were 5 years ago. And this is largely thanks to a project called Project Fugu. And it's an initiative which started with the Chromium team, but has now grown to be like a collective project with contributions from like Microsoft, Intel, Samsung, and the core Google team as well. So what exactly is Project Fugu? So it's an effort to close gaps in the web's capabilities by enabling new classes of applications to run on the web. So this project was needed because typically getting new features standardized took a long time and didn't involve as much iteration and feedback with the community as needed. So with this project, they're taking that same existing approach, but adding like an extra emphasis on iteration. And soliciting feedback is now done much earlier in the process to just allow for fixes and changes to be made earlier. And this results in them just shipping better and more tested APIs. So what's been shipped in these last 5 years, both under Project Fugu and outside of it? So first, let's look at those critical capabilities I mentioned earlier. So push notifications, background sync, and access to the device. So let's just start with push notifications and badging. And this requires a few different parts, and there are a few different APIs that have been created to handle this feature as a whole. So we have the notifications API, which controls the permission and display of a notification message. The push API, which allows the browser to receive push messages from a server. And then the app badging API, which controls the badge on the application icon. So with these three APIs combined, we can provide that native-like experience. So we would start by requesting permission from the user to display push notifications in the first place. And we do that using the notifications API. At this point, we can actually already display a notification directly from the browser. So we can do this by creating a new notification instance and passing in the message we want. So all day, hey, how you doing? And but even though we can do this, obviously this isn't really how notifications work. There's the push element to them, in that the messages are coming from a server, not like just directly within the browser. So to do that, we need a bit more setup. We've already done the first part, so getting permission from the user to send notifications to their device. And next, what we need to do is get what's called the push subscription and then send that to a server so we can have an identifier for the particular device. So to do that, we need service worker. So after we've registered our service worker, we can subscribe to the push manager, passing in some private keys and configuration options. And then finally, we save that push subscription to our server or whatever database we have. Then once the details are sent to our server, then the server can then initiate a web push protocol request, sending the push message to the device. And this push message is received in our service worker push event. And when received, we can then display it using the show notification method. So setting the application badge icon is even simpler. The entire API is just these two methods. So we use set app badge to set the number that should show as the badge icon. And then we use clear app badge to clear the app badge. So yeah, very simple. So let's look at the browser support for these APIs. So the Web Notifications API has been around for a while. I think it's one of the APIs that predates Project Fugu. So the support is pretty decent, even though it's missing a major market in iOS Safari. And support for the push API is also pretty decent and almost the same as notifications API. I added this asterisk to desktop Safari because it actually does support a form of push notifications, but it's just not the web standard. It's a custom implementation. If you're interested in learning more about that, I'd suggest watching this WWDC video, which outlines how to implement it. But summary is that it does exist. And finally, the newest API is the one for setting the app badge, and it's only about a year old, so it's only supported or mostly supported in like Chromium-based browsers, but we obviously expect more adoption as time goes on. So next we have the feature of background sync and fetch. And again, we have a few different APIs relevant to making this work. So the background sync API allows us to defer actions until the device has a stable connection to the internet. With background fetch, we can perform long-running fetches or downloads in the background. And then with periodic background sync, we can specify sync tasks to be done periodically in the background. So it can be a bit confusing to differentiate between these three APIs. So let's take an example of like a chat messaging application to illustrate like when each of these would be used. So for example, let's say a user is trying to send a message but loses connectivity. So maybe they're like on a train or wherever. So we'd use the background sync API to schedule a task to send the message for when the user comes back online. And here's how that works. So first we register a sync task with a particular identifier. And then in our service worker, we have the sync events, which will be fired when network connectivity becomes available. And then when that event is fired, we can then look at the tag of the sync event that we scheduled and perform whatever task we need. So in this case, we'll be like sending the chat message. So next, let's say a user has been sent a video or a bunch of photos in the messaging app that they want to download, but they don't want to sit there like with the app open, waiting for all the photos to download before they can exit the app. And that's where background fetch comes in. So using this API, you can perform a bunch of like fetch events in the background with the web app not necessarily being like open or active. And we just get features like having the progress of the fetches being available to the user within the like device system UI. And here's how that would work. So again, we have, we'll like register the background fetch task, and then we'll pass it an array of files that we want to like fetch and download, as well as some other like options about like how to display like what is being downloaded within the device. And then we can actually keep track of the progress of the download with this event listener on the fetch task variable that we created. So we can do things like show the download progress within the app itself. So like you can see, this is not within the app. It's like a system-wide UI. And in our service worker, we have a few events that we can listen for to actually just determine what's going on with the background fetch and handle it however we please. So finally, we want to have new messages already fetched when the user opens up the progressive web app. So we don't want them to have to like open the app and then start fetching all the new data. We kind of want the app to feel as up to date and fresh as possible. And that's where periodic background sync comes in. So we can set a schedule to perform a certain task at a certain interval. So for example, update the messages every day. And the way this works is very similar to the background sync API. So we just register a new periodic sync task, setting an identifier and how often we want to perform the task. So in this case, once a day. And then in our service worker, we have this periodic sync event, which will be fired when the browser allows for a periodic sync. And then similar to how we did for background sync, we just check the relevant tag and perform the relevant task. So in this case, fetching and updating the chat messages. So now let's look at support. So with the background sync API, we're still relatively restricted to Chromium-based browsers, despite the fact that it's actually been around for a number of years now. This is similar for the background fetch API and the periodic background sync API. So although we're in a state where we can use these APIs with a fairly significant amount of people, we also have to equally consider that these features are not something that we can rely on existing for all users. So our third critical feature for a progressive web app to be capable revolves around the web app's access to the device. And there are many APIs related to this, but I'm just going to focus on these three since they're some of the most requested by developers and users. With the Contact Picker API, a progressive web app can have access to the contacts on the device. So if the feature is available, we can select certain data from the contacts on the device. So we can choose to pull name, email, phone number, image of all the contacts. This is a mobile-only feature, so it's not available on any of the desktop versions of these browsers. That said, support is pretty good, average, all right. Next, the Web Share API. So this API allows us to share data from our progressive web app to other applications. So if the feature is available, we can share things like links, files, and images from our progressive web app to any other app. On the flip side, a progressive web app can also be a target of shares from other applications. So we can set our web app to be an option when sharing certain types of data from other apps. And we do this in our web app manifest. So we add this share target object. And in this example, we're just allowing our app to accept basic data like links and text, but you can also set it up to be able to accept more complex things like images or other media. Then when the data is received, we can handle it however we choose. So in this case, I'm just displaying it there. And support for the Web Share API, so sharing data from your progressive web app to other apps is pretty good. For Web Share targets, so the other way, the support isn't as clear. We know for sure it's supported by Chrome and Edge, and it's not supported in Safari, but not so sure about some of the other browsers. So finally, we have the File System Access API, and this grants us access to read and save changes directly to local files on the user's device. So this is how we'd read a local file. So first, this has to be wrapped in some user-initiated event, and then to open the file picker, we use this window.showOpenFilePicker method, and then we have access to the file picked here. And then assuming that the file is a text file, just for this example, we can then get the context of the file to do as we wish. And then on the other side, we can then save back to that same file saved on the user's device. So we just create this writable variable, which we can write to using whatever the new contents of the file are. And then finally close it off. And this is what that looks like. So before a file is open, it usually asks for permission, but since I've done this before, it skipped that. But once I've selected the file, I added it to this text area so I can then edit it. And then when I click Save File, it saves it back to that same file. And if you were to open it up again, like in a different thing, it will show the edited version. Support for this API is very limited. It's one of the ones that's just released in the past year or so. So I guess it's expected to be a bit limited, but hopefully support will improve a lot soon. So as I mentioned, there are so many APIs shipped by the Fugu project that I couldn't really get into today, but I suggest that you check them out and this Fugu tracker website, which just shows everything that's from being shipped to in testing to just ideas that they're considering. And you can also figure out how to submit an idea yourself if you're interested in that. So where are we with web capabilities today? So as we've seen, a lot of progress has definitely been made. However, not all platforms have made the progress equally. So looking at Android, I would say we're actually getting very close to parity with native applications. But iOS is essentially not that different to how things were like 5 years ago. That said, we're still generally in a better place. So I gave it this sort of like half smile, like we're kind of making progress. So next, how reliable are progressive web apps today? So how much can we ensure that progressive web app will like exist and function well independent of network? As I mentioned before, service workers are the key to achieving this. And as you can see, we are in a much, much, much better position with support today than we were 5 years ago. So essentially every browser that is going to support service workers and should support them already does. We also have better tools for developing service workers. So most browsers now actually allow us to like see and debug the service worker and its life cycle a lot easier. So we have more visibility into the different events that a service worker is tuned into, and we can like simulate a push message, a periodic background sync event, all of that stuff. One of the greatest improvements to the experience of writing service worker code is the introduction of tools like Workbox. So Workbox is a really great library that provides easier ways of doing the most common tasks that we all need service workers to do. So they also provide a set of recipes to do these common things, so making writing this like boilerplate repeatable code a lot easier. So for example, we have a recipe to just cache like all the JavaScript and CSS files from our page while still making sure that they get updated in the background in case there are actual changes, as does happen. So it uses this register route function from the Workbox routing module, which allows us to take like a particular fetch request from our document. And in this case, we're checking to see if the request is for like a script or a style document. And if that's the case, we want to use this stale while revalidate function from the Workbox strategies module. And what this does is it will return a cached response if that's available, and then update the cache in the background. So without Workbox, this flow is something that would take like a whole lot more code and a whole lot more headache. And another thing we can do with Workbox is track Google Analytics even while offline. So it's as simple as these two lines. So we import the relevant library and then initialize it, and that's basically it. But probably more importantly, we have recipes for like caching an offline page and then serving it if the user goes offline. So the first part, which is just caching the offline page, uses just regular service worker code. And that's one of the great things about Workbox. Like as a library, it doesn't interfere with you just interfacing with service worker directly. It's just something that you can add on top of it. So in the service worker install event, we open a cache, which we're calling offline HTML, since that's what we're going to be storing in that cache. And then we add the URL to the offline page. And next we serve the offline page, and this is where like Workbox comes in to like make things easier for us. So similar to how we registered the routes to handle like style and script requests, we can register another one. And to handle this one, we're going to use the navigation route class, which handles routing related to navigation. So as opposed to like the fetch requests for like style and scripts, as we saw before. And then we pass in our custom navigation handler function. And in this function, we first try to get whatever request from the network only. But if that fails, we return with the fallback HTML page instead. And here's what that looks like in practice. So when I'm offline, the page renders. And as you'll notice, actually like the style sheet and the fonts still load because they were cached previously. And then when the user comes back online, their Google Analytics data is also going to be sent by that offline analytics library that we used. So what about the app shell model? So it's still the preferred way to provide an offline first experience, like having the shell cached and then the data provided like dynamically afterwards. But today we have much better support to integrate this model using like frameworks that we are already using. So every major framework now has some form of support for progressive web apps and like the offline first and app shell model. So with Angular, there's like this guide on how to implement the app shell. We have similar guides for React and Vue. So I would say that in terms of reliability, progressive web apps are doing very well. So the support for the tools needed, like Service Worker, are widespread enough that we can generally expect it to be supported for most users. And the experience of developing service workers has also improved to the point where it's more accessible to more developers. So finally, are progressive web apps now installable? And first, support. So this is definitely looking a lot better than it was 5 years ago. Almost all major browsers, particularly on mobile, have the support for this feature or are working towards it. And even iOS Safari does support the feature, just not within web views. And although the level of install integration differs between browsers, they all have some form of progressive web app install available. So what about the requirements for adding to home screen? Like, how have those changed? First, as before, we need a web app manifest. Different browsers have different requirements for what is needed in a web app manifest. Luckily, there's now like a ton of websites that you can go to that will generate this file for you by just like filling out a simple form. Secondly, the domain must be secure. So this is necessary since like progressive web apps are going to be using features that require handling of user data, but it's also just best practice for most websites now anyways. And then next we need the service worker, and this isn't actually a requirement in all browsers, but guessing if you're building a progressive web app, it's something you'll need anyway because you're using some of these features that require a service worker. And one thing to note about this is that I think in a few months, maybe just like in a couple of months now, Chrome will require that your service worker actually also returns a valid response in the fetch event, even when you're offline. So this is a move to making sure that an installable app actually acts like an installable app, like it's usable even without connection to the internet. And finally, we have this user engagement heuristic. So although this is technically still in any documentation I could find, particularly like in Chrome, it doesn't really seem to effectively mean anything. So in most cases, the add to home screen prompt is actually still displayed even like on a first visit. So I kind of just consider it not really like that used or used at all anymore. And more so, we even have better control over the install flow instead of it being something like wholly controlled by the browser. So we can now detect if a progressive web app is able to be installed with this new event, this before install prompt event. So this event is triggered just before the default browser install prompt will show up. So we can actually intercept it and provide a more custom experience. So for example, we would stop the install prompt from showing as it usually would, and then we would save the reference to the install prompt so we could then call it in our custom flow. So then we could like show our own custom install prompt, including like any marketing materials or however we wanted it handled. And then when the user clicks on our own custom install button, we'll then show that prompt that we saved from earlier. And we also get a reference to this variable, which lets us know like the outcome. So if the user actually did choose to install the progressive web app or not, and then we can do whatever we need to do based on that. And finally, we have access to this app installed event, which lets us know when the progressive web app has successfully been installed. And in this event, we would do whatever we need, like hiding any install UI or anything else that we need to do to clean up. And this is how that works. So before the before install prompt event is triggered, I display that install button. If it isn't triggered, the button wouldn't be displayed at all. And then when a user clicks it, they see the pop-up to confirm that they want to install. And then I can handle everything from there. So we are actually getting closer and closer to add to home screen really becoming installing. So although it's not exactly quite there yet, we're seeing a lot of incremental improvements leading us towards that state. For example, we now have a concept of web APKs. So a web APK is essentially a native application package that's created entirely from a progressive web app. So it's done automatically when a user just clicks add to home screen or install. So it doesn't actually require anything extra from us as developers of these web apps. It's done completely behind the scenes, which is great. And we get a lot out of a progressive web app being packaged as a web APK. So first, it's displayed in the app drawer along with other native applications. It also has this app info page, the same way that other applications do, at least like in on Android. So there's a more like central and standardized way to handle different settings. And we also have these intent filters, which allow links from the website domain to be open in the application instead of the browser. So with web APKs, our progressive web app is very close to being treated like any other Android application. Another thing I'd like to mention is this concept of TWAs. So TWAs, trusted web activity. It's a way to open a progressive web app from within like a native Android application. So it uses a protocol based on custom tabs. So they're sort of like a web view, but a web view that's intended only to load a domain that you own and control. So meaning that like some special access can be granted. So you kind of may be wondering like, okay, what are the use case for a trusted web activity? And I basically see like two scenarios where a TWA would be used. So the main use case, I think, is someone that already has an Android application, but wants to move some dedicated pages to a progressive web app to get certain benefits. So you might have like an about or a help section of your app that's updated frequently, and these views can be changed or converted to TWAs so that you get the benefit of being able to update it a lot more frequently without having to go through the whole uploading a whole new like build of your app. And over time, you can actually transition more and more of the app to the web version as needed. Or we might want to go the reverse way. So let's say we have like a fully fledged progressive web app, but our app requires some particular feature that's currently only available to like native Android applications. And so you can do it this way, where very like select or specific pages will be native, but most of the app is the web view of the progressive web app. So in summary, like a trusted web activity is just kind of a useful combination of these technologies. So you can choose which portions of your app need to be a PWA versus which part needs to be like a native application. And it's kind of just a reminder that like the web and mobile technologies don't need to be like antagonistic. They can actually exist together, and we as developers can decide like, okay, what technology should be used where. And getting into TWAs is a bit outside the scope of this talk, but if you're interested in checking them out, I'd suggest you check out this library called Bubble Wrap, and it was essentially designed for front-end developers to launch their PWAs as TWAs. So in terms of installability, I think progressive web apps have made a lot of progress. So like capabilities, not all platforms have made like progress equally. Like I've mentioned, Android is significantly ahead of iOS again, but as a whole, I think we are in a really good position. So what's next for progressive web apps? Where do we expect to be in, let's say, like another 5 years? Obviously, the goal is to get to a state where progressive web apps can be truly capable, reliable, and installable, even to the extent that they exceed native applications, even though I don't really know what that would mean. To get there, we still need to make a lot of progress with capabilities. So there are lots of features currently in the pipeline that should keep moving progressive web apps closer and closer to feature parity with native applications. These are just some of the APIs that I'm personally really excited about and are already either in development or under consideration. So things like being able to access local fonts local to the device, or having like tabs in a progressive web app, detecting orientation, widgets on the home screen is another really good one. Detecting screenshots, requesting permissions at install, having a custom splash screen. There's just like a lot that I'm really excited to come soon. However, although all these features are and will be great, the main thing that needs to be addressed over the next 5 years is the feature parity between the web on different platforms. So currently, the web on Android is miles ahead of the web on iOS, and we need to be really careful not to end up in a situation where the web then suffers the same issues as native applications. The reason progressive web apps are the best of both worlds is because they still have the reach of the web. If there becomes a divide between how the web works depending on the platform, then progressive web apps become no different from native applications. In order for progressive web apps to really be the best of both worlds, the web needs to be the same everywhere. It just needs to be the web. Thank you.